Hello everybody, this is Mrs. Snook with section 5.6, parallel and perpendicular lines. So right where we ended the semester, we had finished sections 5.1 through 5.5 of chapter 5. And there was one more section that we need to do before we move on into chapter 6. So we're going to go ahead and do this section 5.6. We're going to do that now and then start chapter 6 next time. Our objectives today is to determine if lines are parallel, perpendicular, or neither. And we're going to do that by looking at their equations. We're not going to graph them to figure it out. We're going to look at their equations. And we're also going to write equations of parallel and perpendicular lines. So first off, I'd like to give some definitions. So a parallel line looks like these. They go like side by side and they never cross each other. They never touch each other. Key caveat is they have to be in the same plane. So when you look at this picture, the red line and the blue lines, see how they don't cross each other and they're going in the same direction? That's why they're called parallel. Now, symbol for parallel is two little railroad bars like that. You'll probably use that again next year in geometry. And the way that we guarantee that they're going in the same direction is their slopes have to be the same. So parallel means same slopes. So in our picture here, they tell us that the graph of the red line is 1/2 x plus 1, and the graph of the blue line is 1/2 x minus 2. What's the same in both of these is that 1/2 x. So for both of these, slope is going to equal 1/2 for both. The only thing that's different is their y-intercepts. Okay, so very simple. If they're parallel, the slopes are the same. So now let's write some equations of parallel lines. Parallel, slopes are same. Just keep that in mind. And there's actually two ways you can do this. The first way is by solving for b. So what we want is y equals mx plus b. So option 1 is solve for b. And I'll do that on our first example. Option 2 is going to be started in point slope form and convert to slope intercept. And I'll do that option on the second example. That way you can see it both ways. If I do not tell you which method to use, you are free to choose either way. So first of all, let's do finding y equals mx plus b. Because the slopes have to be the same, and the equation I'm starting with is 2/3 x minus 1, that means my slope has to be 2/3. I also want that line to pass through the point 12,5. So what I'm going to do is I'm going to plug the 12 in for x and the 5 in for y, plug 2/3 in for m, and then solve for b. So y 5 equals 2/3 times x, which is 12, plus b. Now everything is numbers except that b, so I can solve for b very easily. My 3 and 12 cancel, that leaves 4. So I get 5 equals 8 plus b. Now subtract 8 from both sides, and I get -3 equals b. So now my equation is going to be y equals 2/3 x minus 3. So that's your first method. Second method is start in point slope and then convert to slope intercept. And right here we have your x and your y. And I know that my slope is going to be parallel, so I'm going to start at y minus y1 equals m times x minus x1. Plug in the -3 and the -1, and plug in that 2 for the slope. So y minus a negative 1 equals 2 times x minus a negative 3. I'm going to clean this up a little bit. All those parentheses can be really hard to look through. So minus a negative makes a plus. So y plus 1 equals 2 times x plus 3. Okay, now I'm in my point slope form. Let's convert this to slope intercept. First thing I want to do is distribute that 2. And I'm coming over here for room. So y plus 1 equals 2x plus 6. So I just did a distribute. And then just subtract 1 from both sides. Y equals 2x plus 5. And we're done. Either method is fine with me. Next idea is perpendicular lines. So take a look at this picture. When lines are perpendicular, they cross, and the angle that they form where they cross is a 90-degree angle. Symbol is like an upside down T, and that means it forms 90-degree angle. And mathematically, we say that that angle is 90 degrees if, when you multiply those two slopes together, you get negative 1. So it says right here in words, two non-vertical lines, meaning, they're not going up and down. They are perpendicular if you can multiply their slopes together and get negative 1. A vertical line is also considered perpendicular to horizontal all the time. So if I give you a line like this that's vertical, the horizontal one would be perpendicular. And the reason we have that is vertical lines have an undefined slope, so you can't multiply them together to get a negative 1. Now the way I like to think of this, it makes it so easy, is I like to think that those slopes are opposite reciprocal. So the words I use are flip and switch. And what I mean by that is take the slope. So if I look at the slope of the red line, that slope is 1/2. Here's the flip. I just flip it over. I get 2/1. So that's the flip. Switch. Switch the sign. 1/2 was positive. Now it's going to be negative. So that's our switch. Flip. Take the reciprocal, just flip it over, switch, change its sign. If it was positive, make it negative. If it was a negative, make it a positive. So then the slope for the perpendicular line, notice I wrote it over 1, that reduces to negative 2. You don't have to have that 1 there in the denominator. So that slope is going to be negative 2. And if you look right here, it's negative 2. And then, because I told you you could multiply them together to get negative 1, let's check and see if flip and switch worked. So I'm going to take 1/2. I'm going to multiply that by negative 2. Those cancel, and so I'm left with negative 1. Okay, flip and switch, easiest thing ever. So now let's take a look at some equations of lines, and we're going to decide if they're parallel, perpendicular, or neither. And here's our criteria. For parallel, slopes have to be the same. For perpendicular, flip and switch. Now, if neither of those happens, then it's a neither. So I'm going to look at our first equation. We have 4y equals negative 5x plus 12. Now that's in standard form, so I can't pull out the slope just by looking at it. I'm going to have to do some work. So 4y equals negative 5x plus 12. And what I'm going to do is I'm just going to divide both sides by 4. So I divide this side by 4, I divide this side by 4, and I get y equals negative 5 over 4x plus 12 over 4 is 3. All right, let's look at our other equation. We have y equals 4/5 x minus 8. Okay, so now I have both equations set so I can look at their slopes. The slope for my first equation, I'm going to call this one m sub 1. That's a negative 5/4. The slope for my second equation, I'll call that m sub 2, is 4/5. I've got to flip and switch. Do you see how if I take that 5/4, flip it over, I got 4/5? And you see how one is negative and one is positive? That's a flip and switch. So this is perpendicular. Okay? Look at the next one. We have y equals 3/4 x plus 7. So this one is already in a slope-intercept form. Now look at my other one. 4x minus 3y equals 9. Again, standard form. So I'm going to do some work. I'm going to subtract 4x from both sides. I get negative 3y equals negative 4x plus 9. Now I divide both sides by a negative 3. So divide that by negative 3, divide that by negative 3, divide that by negative 3, and I get y equals 4/3x minus 3. So now I'm going to compare. I have a flip. I have a 3/4 here, and I have a 4/3 there. So I do have a flip. But check their signs. They're not opposite signs. I don't have a switch. Just a flip, no switch. So therefore this one is neither. Okay, so now we're going to write an equation of a perpendicular line, and it's going to go through a specific point. And just like before, I've got two ways I can do it, and I'm going to go ahead and do this both ways. So the first thing I need to do is take the slope of the original and do a flip and switch. So right here is the slope of my original. It was 1/3. Flip and switch becomes negative 3. And I'm going to use that in my y equals mx plus b. And here's x, here's y. So y, move this up a little bit. So y equals mx plus b. Plug in x, y, and m. So 4 equals negative 3 times 2 plus b. So 4 equals negative 6 plus b. Go ahead, add 6 to both sides, and I get b equals 10. So now my equation is y equals negative 3x plus 10. Okay. Next one, let's do this in point slope form. First thing I want to do is find the slope from my original equation. Y equals 2x plus 1. So the slope in the original is 2. The slope I'm going to use, flip it, 1/2, switch, change the sign. Okay? Now your temptation is going to be just to flip the slope, plug in that new slope, and be done. Problem is your y-intercept also changes. So please don't try to do the shortcut. Just go ahead and either find b like I did in example 5. And if you'll notice, the b for the original equation was negative 1. B for the new equation is 10. They're not the same. So don't just flip and switch the slope. Actually find out what your equation should be. So I did the flip and switch. Now I'm going to plug in my 0.18 into point slope form. So y minus 8 equals negative 1/2 times x minus 1. I'm going to go ahead and distribute my negative 1/2, negative 1/2 x plus 1/2 equals y minus 8. And now just add 8 to both sides. Y equals negative 1/2 x plus 8.5. Done. I'd also be fine if you wanted to switch the 8 into 16 over 2 and then add it. And if you do that, you would get y equals negative 1/2 x plus 17 over 2. That's fine as well. Last one is a real world problem. Remember, do your 3 reads. So pause here and do your 3 reads. I'm going to be right back with you to solve this. Okay, so in our reading, we know that we have an architect who's trying to design the ceiling of a room. And he has a beam that he's representing with a red line. And I'm going to show you the pictures right here. And then he has a point over here, which is this blue dot, where his new beam has to go through. And they have to be perpendicular. So I want a line that's going to do something like that. And it's going to be perpendicular right there. So I want a 90-degree angle there. And the way I'm going to do that is I'm going to find the slope of my original. I'm going to find that blue dot, find that point, and then I'm just going to write the equation like we did in our previous examples. So first of all, slope of my existing, so slope of the red line. I'm going to start at 12. So this is the point 12, 0, and the other point is 0, 8. So starting down here at this point, I have to go up 8, and then I have to go backwards 12. So my slope rise over run is going to be up 8, backwards 12. That's going to reduce to a negative 2/3. So now the slope for the blue line, flip and switch. So slope blue is going to be 3 over 2. There's the flip. I started off negative, so I'm going to make it positive, so I've already done my switch. Now the next thing I'm going to do is write the equation. And this point here, let's go ahead and get this point. This is at the 1210 is our point. So let's go ahead. So y equals mx plus b. I'm going to plug in 10 equals 3/2 times 12 plus b. Now this 2 and the 12, they cancel, and I have 6. So 10 equals 18 plus b. Subtract 18 from both sides. b equals negative 8. So then the equation for the new beam is going to be y equals negative 3/2 x minus 8. Done. All right, that's it for today's video. Thank you for watching. Have a great day.